Okay, we are looking at quality control in one of the, which is in quality management, the topic in quality, quality management. Okay, so quality management has a number of topics. But as for now, in particular, we are looking at a topic called control charts. Okay, so we are looking at topic called control charts. Okay, and this is one of the cardinal topics in quality management. Okay, now before getting down to the aspect of the full control charts, we need to actually understand what control charts are. All right, so control charts are statistical tools used to monitor and control a process or a system over time. They actually provide a graphical representation of process data, enabling the firms or organizations to identify the patterns, the trends, and the variations that may occur within the process. Of course, we need to understand the primary purpose of control charts is to distinguish the common cause variations and the special cause variations in the process. Then the common cause variation refers to the inherent variability that is present in a stable process, while a special cause variation indicates a deviation from the normal operating conditions. Now, there are 4 control charts. So we have the 4 control charts. So we have the 4 control charts. The first one is the R chart. R chart. This R chart is also called range chart. So our R chart is also called range chart. Then we have the other one, which is called the C chart. Okay, so we have the C chart here. This one is called also number of defective chart. So this is number of defective chart. Is the number of defective chart. Then we have also the other one. It is the P chart, percentage of defective chart. So P chart. Okay, this is also called percentage of defective chart. Percentage of defective chart. Percentage of defect chart. or defective chart. All right. So this is on aspect of the, of course, we get to the last chart, which is an X bar chart. Number D is our X bar chart. When mean is known, but standard deviation not known. Standard deviation not known. So this is also, now we have also X bar chart. X bar chart when mean is known and standard deviation known. And the standard deviation known. So this is about the aspect. There are only 4 control charts as we get to these control charts. All right, so the X bar, the other chart, the C chart, the P chart, we also have the X bar chart. All right. Of course, let us now start with the R chart. R chart. This one is also called, so the first one is the R chart. Of course, also known as the range chart. The range chart. All right, so under this R chart or range chart, our R bar is the center line. So it's a center line. And now you find the R bar is equal to summation of R over N. The lower control limit is equal to D3 R bar. The D3 is actually given in the table, the statistical tables. LCL is lower control limit. This one is our lower control limit. Then this other one is the upper control limit. We have upper control limit. This is only this one. So upper control limit is equal to D4 R bar. These ones, so this is our D4 R bar. That's the way. So that is it on the R chart, the formulas. Then our C chart, number of defective chart. So this is on number of defect chart, of defective chart. So meaning that our C bar is center line. In the lower control limit is equal to C bar minus 3 C bar. Then upper control limit is equal to C bar plus 3 the square root of C bar. Then we go into our P chart, percentage of defect. So P chart is a percentage of defective chart. All right. So P chart is this one is a percentage of defective chart. So this is only the C chart. So P bar, now the way, first of all, before getting down to the C bar, so C bar equal to summation of X over N. It's more like the mean. It's more like the mean here. So we get to the one for P bar is equal to summation of P over N. That is only the mean for the proportion. Then we also call the center line. So it's a center line. Then we go for, we are from talking about P chart. We talked about R chart. Okay, when we can go for the lower control limit. So lower control limit is equal to P bar minus 3 then P bar open brackets 1 minus P bar over N. The upper control limit is equal to P bar. All right. So P bar plus the 3, then P bar 1, so it's supposed to be 1 here, minus P bar over N. This is how you find the upper and lower control limits. This is for the P chart. Of course, the lower control limit in some other books, you may find or say P bar minus 3, and then PQ over N. Of course, we know our Q is actually, so where our Q is 1 minus P, getting down to that one. So this is our N. All right, so getting down to the upper control limit. Upper control limit is equal to P bar plus 3. Then you say PQ over N. All right, so this marks the end of the P chart. All right, we're getting down to formulas. Then X bar chart is a mean chart. Okay, this one is called the mean chart. And then on this one, what are we saying? X bar is the center line. Now, what are we saying? This X bar chart, number D, is when the mean is known and the standard deviation known. So mean is known and standard deviation known. Standard deviation known. Okay. So X bar, the lower control limit is actually equal to, okay, X bar minus, so X bar minus, so this is minus 3 standard deviation over the square root of N. Okay, so this is when the mean is known and the standard deviation known. It's given by this one. So this is minus. Then the upper control limit is equal to X bar plus 3 standard deviation over the square root of N. Now, this one is called the standard error of the means, which is equal to standard deviation over the square root of N, called standard error of the means. Standard error of the means. All right, so this is standard error of the means. Okay. So this is when the mean is known and the standard deviation known. X bar chart, when the mean is known but standard deviation not known. Okay, so the standard deviation not known. So what happens on this one? I simply say our X bar 2, in this case, is a center line, not X bar 1. So center line. Then what next? Our lower control limit is actually going to be X bar 2 minus A2 R bar. Then upper control limit is equal to x bar 2 plus A2 R bar. This is on, what is what goes on. All right then, so these are the 4 control charts that are there in quality control. Okay, of course the basics are here, why the control charts are important, and then how we need to find how the 4 control charts exist: the P chart, the R chart, the C chart, and an X bar chart. So if it asks you to find, how many control charts are there, we have all those control charts. We have that one. So we look at the center line is what the guiding point, the control limits, upper control, be it upper control, the lower control limit, and then getting down the data points. So now, why do we do the control charts? We do control charts in order to determine if the process in statistical control. So control charts, see, they determine if the process is in control or out of control. Control charts determine if the process is in control or out of control. So these ones determine if process is in control or out of control. All right. So if we have a diagram of this nature, then our center line is here. This is our lower control limit, our center line, and of this one. So an example, if this is our R bar, and this is our lower control limit, this is our upper control limit. So if all data point 1, data point 2, data point 3, data point 4, data point 5, data point 6. Okay, so 5, 6, 7, maybe 8 here. So if any data points as we draw, if it is in this, then within the boundaries, it means process is in control because it falls within source process in control. So we are simply saying it is when data points are within lower control limit and upper control limit. So process in control, data points are within lower control limit and the upper control limit. Okay, so upper control limit and the lower control limit. All right, so the process is in control. Okay, so this is about what goes on as we are looking at Yeah. So this is about the process being in control and processing not in control. So, but now this is going, we are saying process is in control. Okay. Getting down to the other one, we can have this kind of arrangement where we have the lower control limit, and then this one is our C bar, our C chart, and then here we have the upper control limit. So when you have anything like this, so the process is not in control. Process is not in control. Why the process is not in control? If data points are above or below the control limits. So meaning process is no control, meaning process is not in control. Process is not in control. All right, so this is about what goes on as in process being control or process out of control and control charts. So this marks the end of the control limits. Of course, we can do an example concerning these 4 control charts that are cardinal in quality control for this kind of for this course. Of course, the 4 of them that we mentioned about the other chart, the C bar chart, the P chart, and then getting down to the other ones where we look at the X bar chart with the mean known and the all that. Okay, so we'll now get down to the example quickly. We do an example concerning these control charts. Okay. So the example you can get from the one of the assignments that could have come. So we can now get to the example. Okay. So under the control charts, we can look at this example. You have been hired as a consultant. This one is just about quality control, quality management, the GBE PM 620. Now, there is this question 1, which says you have been hired as a consultant by Good Times Company, which produces industrial adhesives. The general manager, Angelina Kalinda, is concerned about the number of issuing relating to the production of the adhesives and the filling of the adhesives into tubes. As a preliminary check, 6 samples of 8 tubes were taken, and each tube was weighed as shown in the table. All right. Then there is a need for us to get down to the question, the sample. We had 6 there, and then the tube number, we have up to 8 there. All right. So they have told us about the number of issues relating to the adhesives and the 6 samples of tubes of those. All right. So develop the control charts for the adhesives for the above information. Develop the control charts for the above information and provide an explanation of the findings to Miss Kalinda. All right, so now what goes on here is that there are 6 samples, so we have to find the standard deviation is not given here. And of course, the samples, there are 6 of them. So we need to find the mean. So here, when the standard deviation is not known, but the mean can be found, so we can use the control charts to use here. There are, of course, 2 of them to develop the control charts for the above information. So we can use an X bar chart. And then, even if they didn't say, we can use an X bar chart. And we can also use our R chart, because we can find the range for these ones that we actually looking at. Okay, so getting down to the solution before getting down to the specifications, because the specifications, that is another topic altogether. But since we're on the control charts, let us see what goes on. So under the solution, what we need to do, and then we have to find an explanation if the process is in control or the process is out of control. So getting down here, we have to find an X bar. So it's a mean of each of these ones. So we find addition of each of these ones, an example, to find an X bar. Okay, so we use the X bar chart. There are 2 charts that are involved here. Okay, the X bar chart and the R chart. The X bar chart will be used in a scenario when the mean is known and the standard deviation not known. So we're going to use this one. The mean can be known. Here we have to find the overall mean, and then the standard deviation not known. So we can use this kind of formula. Of course, the other one we'll go for is a range chart, where we have to consider this one. All right then, so we can get down to the question where we find the average samples. We are finding the means. These are X bars. So it says an X bar, which means it's a mean for each sample. Then this is the range, or R, for each sample. So our X bar to summation of all these ones, divide by how many they are, 1, 2, 3, 4, 5, 6. So we're getting 8.07. That's our X bar 2. Our X bar 1 is on top there. All right, so that is our finding there. The X bar 2, 8.07. So when getting down to the control charts, the X bar 2 is the center line. So this is our center line. Then what else? Lower control limit is equal to X bar. So X bar minus A2 R bar. Upper control limit is equal to A2, that is X bar, plus A2 R bar. This is about this kind of one that we need to go for. So A2 is obtained using our N6. Our N is 6. from the tables will be provided in an exam. So in the table, that's where the A2 R bar is 0.38. R bar is the average for this. Our R bar, we know summation of R over N, or R bar is equal to summation of R over N. Okay, this is only our R bar. All right, so this is according to what is going on. So now after plotting here, we can see where all these figures fall, the 8.04, 8.26, 7.94, 8.05, where these ones fall. So for sample one is 8.0. So this process is not in control because this data point is above the low. This is upper control limit. Then this is our lower control limit. Lower control limit is 7.93. This is a lower control limit. So this point is above. So the process is not in control. So tube number, okay. So sample number 2 is above the control chart. So the process is not in control. So sample number 2 is not in control. For as long as one of the samples is above the control limits, so the process is not in control. So this process is not in control because it's above the upper control limit. Similarly, when getting down to the other R chart here, our R chart, we have the R bar is a center line. Okay, so this is our center line. And then how will we get our R bar? Is equal to summation of R over N. Of course, where these other figures are coming from, the 0.3 is coming from the table. So the tables are provided using N6. The N6, and we'll go for A2. That will be explained by getting down to the table. The table will be provided. But we need to get these ones. These are getting from the table, which are called quality control tables. The same way we get from the standard normal tables for normal distribution. So N6, and then we go for A2. So this one is where this one is obtained, 0.373. All right, then we'll get down to the R chart. So this is our R chart. This R chart, we plot these using the data here, the ranges. For sample 1, the range was 0.76, 0.43, getting down to these ones for each sample. So the sample 6, then we're getting the ranges. The first one is 0.76. If one of them will be above or lower than the lower control limit, then the process is actually not in control. All right, so getting down to this, so his process is not in control. The process is out of control because we have this parameter here, 0.76, is above the control chart. And then what else are we having? The other one is only the 0.05. Okay, 0.05. We have that one. So this is our control limit and upper control limit. This one is above, so process is not in control. So for each of the control charts, this is about what goes on as we are looking at the process capabilities. Now, getting down to the other question here, which is on question number 2. Question number 2 is actually on the P chart because we're finding the proportion of defective from the sample. So this is a P chart, percentage of defective chart. So this is on P chart. This is percentage of defective, percentage of defective. Under this one, we already know for real for sure that our P bar is a center line. It's a center. Then we find it using, so I find average, so meaning that the defect was this, so it was 3 divided by 144, which is giving us the amount that is indicated there. So 3 divided by 144, 0.03. So this is this one divided by that to get there. And then finally, the proportional defective, which is 0.03. Then getting down to finding the lower control limit. So here, the formula on this one is lower control limit for the P is P bar, and then minus 3 is standard. Then we get to P bar 1 minus P bar over our N. This is how you get a lower control limit. So we got these ones. Then our upper control limit for the P is opposite to P bar plus 3. Then P bar 1 minus P bar over N. So here we can see that for this one, for this is upper control limit. This is P bar, the center line. This is the lower control limit. So process is in control for that one. All right, so the capability is in control since all the points random are within the control limit. Since all the data points are within the upper and the lower control limits, process is in control. Process in control. So this is just about what goes on as we look at the control charts. Top number of defective chart. This is the C chart. C chart, T bar is a center line, summation of X over N. All right, so this is about where we get to the this kind of one, the one we're talking about concerning the C chart. So which is 4, then getting down to all these up to 12. So we check even this is in control because they are within the upper control limit. It's a C bar, which is 4. And then this is upper control limit, upper control. Then the other one is actually lower control. Okay, so we're getting down to the upper control limit, and then we get to the lower control. So meaning that the process is in control when all the data points are within the upper control. These are what we are getting. So there's a 10 and 0. So 0 is the lower control limit. This is our X bar, the center line. Then our upper control limit. So within here, you're getting down to the upper and lower control. So the process is in control because we have now the aspect on this kind of control chart. We simply say process is in control, okay, when all data, okay, when all data points are within, so whichever control chart that we look at are within, the first one is lower control limit. LCL is called lower control. So lower control. And then if it is also within the lower control and then upper control limit. So this one is called our upper control limit. So this is when the process is actually in control. All right, so this is what goes on as we get down to this one. So even here for this chart, so all of them came in this question. We have the P chart. Okay, so the P chart is here. These are tube numbers. This is for the C chart. Okay, for the C chart to do with this one. All right, then here we are finding the number of the percentage of defective, number of leaking. So it's a percentage of defect. All right, so this is about the 4 charts, which are control charts that are there cardinal in quality control, quality management. So here we have come to identify that the process is in control because the C bar was 48. After adding here, all these ones, you got 48. Then divide by that. Okay, so we are getting 4 there. So C chart, C bar center line. So this on the control charts, we are done. Then we're getting down into the other, before getting down to this, so this one,